Hello, in this video, through an example, we are going to be introducing the binomial distribution. Let's consider the following spinner that they have here, a picture from the book. Let's say it's fair, nothing weird is going on, and we just spin it, and if we get a white, then we win. So we have two possibilities over here. We spin it, we can get a white, and then we win. And this happens with probability 1/4. Or, well, we could get a blue and then we don't win, no win, fail. And this happens with probability 3/4. Let's say we repeat this experiment n times. So n times we spin the spinner. If we spin a white, then we win. If we spin a blue, then we don't. Let's define then a random variable that I'm going to call x that counts the number of whites when we try the experiment n times. And this is what we call a binomial distribution because it has the following characteristics. First of all, there is an experiment that we are doing n trials, and those trials are independent. So the spinner doesn't know what happened before or what will happen after. Each time that we repeat each time that we repeat the experiment, there are two possible outcomes. Either we win with probability p, or we don't win, we fail with probability 1 minus p. And this probability p and the probability 1 minus p then are independent of which one of the trials we are considering. So this is the same through the whole experiment. If we are in such a situation, we say that our probability distribution x is distributed binomially. This is the name, and we write it with a b, and we use this tilde to say x is distributed like a binomial probability. And we need to say how many trials we are considering, n, and we have to say what is the probability of winning in each of these trials, p, which in our case was 1/4. So we want to see how this binomial distribution looks like, and we will do this with the example of the spinner, but we are going to consider that n is equal to 3, and we're actually going to find the probabilities of the possible outcomes by hand. First of all, notice that the possible outcomes on the number of whites that you could have when you repeat the experiment 3 times, well, the values of x can be either 0, you don't get any white, or you get 1, or you get 2, or the maximum you can get is 3. And we would like to know what is the probability of each of those successes. So what is the probability that x takes the value 0? Well, what do we need to happen for x to take the value 0? For x to take the value 0, it means that each time that we spin, we get a blue. So that means we spin once, and with probability 3/4 we get a blue, and we spin again, and probability 3/4 we get a blue, and then we spin again, and probability 3/4 we get a blue. So this will be 3/4 to the power of 3. Very similarly, we can look at what will be the probability of x being equal to 3. That will mean that each time we get a white, and we get a white with probability 1/4, so it will be 1/4 times 1/4 times 1/4, and this is 1/4 to the power of 3. For the probability of x equals 1 and the probability of x equals 2, this is a little bit more complicated because there are different ways of getting a 1. We could get a 1, so we can get 1 white because we spin white, blue, blue, or we spin first blue, then white, and then blue, or we spin blue for the first 2 spins and then white at the end. Each one of these events has probability, so this will be 1 white, 2 blue. Each of these events has probability 1 over 4 multiplied by 3 over 4 squared. The 1 over 4 will be for the white, and the 2 over 4 squared for the 3 over 4 squared for the blues. And there are 3 events where this happens: white, blue, blue, black, blue, white, blue, and blue, blue, white. And those events, they don't have any overlap, right? Like either happens one or the other. So that means we can sum their probabilities. They're all the same. So we multiply 3 times 1 over 4 times 3 over 4 square, or let me just change the order, 3 over 4 square. You will see why I changed the order in a little bit, just to make the notation more consistent. 1 over 4 to the power of 1. Let's look a second at this 3 over here. How do we know that this is a 3? Well, we are going to have only one spin that is white. We have to decide which one it is. Is it the first one, the second one, or the third one? So there are 3 choices. A more formal way of looking at this being 3 choices is to think that we have 3 possible spots and we are picking one of them. So we need to choose one out of 3 possibilities, and this is the combinatorial number 3. One chooses from 3. So this can be written 3 over 4 squared times 1 over 4 to the power of 1. The case of x being equal to 2, so there are 2 whites, is kind of similar, because to pick which 2 ones are white, that's the same as picking which one is the blue one. So either the first one is the blue one and the other 2 are white, or the second one is the blue one and the other 2 are white, or the third one is the blue one and the other 2 are white. Each of those events has probability 1 over 4 squared multiplied by 3 over 4 to the power of 1. I just write the power of 1 to be consistent. And there are 3 of them again. This is the combinatorial number that we would get if we, well, a combination is 3, 1, but the combination is 3, 2. Also, we're picking 2 out of 3, gives us exactly the same result. Again, I'm going to write the 3 over 4 with the power first and then 1 over 4 afterwards, just for notation's sake, because what I want you to see over here is that actually the values that I have over here are the terms of the binomial expansion of 3 over 4 plus 1 over 4 to the power of 3. Yeah, so if we are writing the expansion of a plus b cubed, we are going to have a cubed plus 3 times a squared b. This is coming from the combinatorial number C31 plus 3 times ab squared plus b cubed. So in this case, my a would be 3 over 4 and my b would be 1 over 4. So this expansion has 4 terms. The 4 terms are the probabilities of my probability distribution, which was what I wanted to find. And if I sum them all, I'll be summing all the possible probabilities. And the result of that has to be 1. And it is 1 because if I do 3 over 4 plus 1 over 4, that's 4 over 4 cubed. So that's 1. So it makes sense that the sum of the probabilities is 1. Yeah, so we introduced the binomial probability in this example, and now we are going to move on to generalize it a little bit.